Hi, everyone. Thanks. Hello. I'm very happy, and thanks for the invitation to talk today. I'm Nicolas, and I work as a contributor to Symfony, the PHP framework. So my job is writing open source code that you can then use to build web applications. Today, I'm going to tell you about an idea I'm working on together with Claude and with friends, real human friends, like maintainers of open source projects, where I can start contributing because I couldn't before without mastering Go, C, etc. This project, this idea, is a pull request that is written in 3 languages at once, and I need the coordination and the help of the AI, of course, because I don't master 3 languages, especially for this kind of topic. So, this is PHP today. The PHP you know, and the PHP that is great at building rock-solid applications, like applications that don't leak memory. It's a difficult problem, and we don't care about this aspect when doing PHP. What we do is that we forget everything between requests. So the first step is we create, here it's a Symfony application, but any PHP application works the same way, of course. We have something that bootstraps the application, then we handle the incoming requests, we flush memory, and we start over every single request. You know this model, right? It's the real strength of PHP. The other technologies are trying to do stuff like Lambda processing and stuff like that. PHP is like Lambda from the beginning because of this memory reset that happens all the time. So here, in this talk, I'd like to focus on something that is very difficult to tackle in PHP alone, which is reconfiguring applications in real time. Like, PHP can't listen, it can only react, ask, and the use cases, I have these 4 use cases. It's like, how do you connect to the correct Redis master when the Redis master is unknown and you need to ask a Sentinel first? That's a common process to talk to Redis in a high availability setup. You go to the Sentinel, you say, hey, Sentinel, where is the master? And the Sentinel says, there it is, and then you go to Redis. And in PHP, because we don't have long-term memory, we have to do this process 2 round trips all the time for every single request. So you gain a high availability, but you lose some performance, and that can be critical sometimes. Feature flag, it's another very common way to reconfigure applications live in real time, and usually we have an open feature server. How do you do the configuration in PHP? You have to do a full round trip to the open feature flag server to get, let's say, a JSON document that describes what is enabled for who, etc. And then every single request means, in PHP, doing the round trip, then configuring the application. That's not how open feature flag is supposed to work. It's supposed to be reactive, which means you're supposed to connect once to the feature flag server with a long-term connection, and then when there is an update, you get a push on the stream, and then the application is updated instantly. So weather data, that's a joke. More generally, config changes, like rotating secrets. Maybe the secret change often. And how do you do that? In PHP, you do round trips to the vault to get the new secrets. That's not how Java and the other stacks do it, and there is some benefit in doing it differently. So maybe if you have an advanced PHP application, you worked around that using a Redis, local closed Redis server that you are using for caching, and then you have a background process that does the reacting or listening to the world and pushes to Redis the actual configuration. That's quite an infrastructure overhead. It's complex. So it means complex because there are 2 systems to deploy, to monitor. You need a store, you need network. You have race concurrencies, like you need to be sure that the configuration is fresh when the HTTP application bootstraps, stuff like that. How do you handle crashes? So you have supervisor D or system D or whatever. Complex infrastructure, you know, microservices enters in the game. Recently, the PHP community has been introduced to FrankenPHP. FrankenPHP is an alternative to PHP FPM. PHP FPM is the way we run application in prod today. And FrankenPHP takes the model and leverages Go. And the vision of FrankenPHP is to have one single process to boot and to deploy. Instead of having, let's say, Nginx and PHP FPM plus a protocol in between, like FastTGI, to communicate and to deploy at some point, you have only one single process that embeds the HTTP server and manages PHP threads, because that's how it's implemented. So this is a Go binary. It embeds Caddy, which is a very efficient Go HTTP server. It's fully, it's featureful, like it replaces completely Nginx or Apache, whatever you're using. But then when a request comes in, FrankenPHP does the job to dispatch that every request to an available PHP thread. And then there are two modes. The regular mode, the previous one, is resetting the memory between every request. So that's very similar to a PHP FPM. And then there is another mode, which is called the worker mode. And in worker mode, we launch a thread and we keep it alive for as long as we want. And we keep it alive, which means every state we have in PHP, in the PHP process, is reused between requests. And so that could be the idea here. You get it. At the beginning, we create here a kernel, and then we enter a loop, and it's an infinite loop. And the closure is called whenever a request needs to be processed. And this is way more efficient because we don't create the kernel all the time. We still handle requests in sequence, but we have many threads in parallel, so we still have a high and great concurrency. So, and then, of course, we gain auto-loading, stuff like that, so it's a real performance boost. It still can't listen to the outside world. We are still in a way where requests are processed, and it's quite difficult to have one central memory where feature flags are updated, etc. So that's the current state of the art, and I've had this vision of, hey, FrankenPHP manages threads, PHP threads. Let's make it able to use threads that don't deal with HTTP, that deal with what we want. Just running a PHP script there, and the PHP script runs for a long time. And FrankenPHP already has this infrastructure to monitor the thread, and if it dies, it creates a new one. So we have supervisor D, systemd built in the process already. So it was just a few lines of code to make it better and fit more use cases. And the use case I want is, of course, the one I already introduced, which is watching the outside environment and push updates to the application, like new features to be enabled, new secrets, new Redis master, etc. Basically, what I want, and the mental model of this, is a whiteboard that is inside the same FrankenPHP process. So it's very easy to refer because it's like the same memory area. And the model is, we have something that I call a sidekick, so this background worker. And the sidekick is the only one that is allowed to write to the whiteboard. And then the HTTP workers, they can only read from the whiteboard. And that's it. One process, just PHP talking to PHP in memory, pointers, stuff like that. Very few memory copies because we are inside the same stuff. So the model is, visually it's like that. We have background workers. They call setVars from time to time when there is an update to the world, like a new Redis master has been elected. This writes to the whiteboard, and then HTTP, many concurrent HTTP requests, they all, at the beginning of the request response cycle, they get the vars, and they know the world. OK? And that's it. I think you've understood everything. So the API is a bit more, as one more function, so set vars, an array, and that's how the worker sets variables about its world. Get vars, there's a name, that's the name of the sidekick, like Redis Sentinel. And this is a set of vars that all configure Redis. Signaling stream, it's for knowing when a thread needs to stop. That's technical because at some point we need to coordinate shutdown of the processes, and we do that through a stream. So the stream gets messages, and the process is supposed to listen to that and take care of just stopping when everything else wants to stop. On the configuration side, so this is a CADI file, which looks like an Nginx configuration tree. So it's a tree, it's not YAML, it's basically the same thing, just a different syntax. And in this CADI file, we define entries, PHP server entries, and there is already a worker entry. What is not existing today is the background keyword. So here we just say, hey, please manage for me a worker that is going to be started with this PHP script. Bin console is the Symfony console application, and I'm making this link between Symfony console and this script because, of course, I want to run a background worker as a Symfony command because I know how to write Symfony commands, and everybody knows how to. So then it's way easier to integrate. It could be anything else. Doesn't matter, Symfony here. What matters is background, and background means not HTTP. Long-running stuff in the background. I can name background stuff, and so this one is a name, Redis Sentinel. Redis Sentinel is going to be given to the command so that the command knows which background worker we want it to run. Num1 is like one at the same time. I'm going to skip that. So this is a poor man's version of the feature flag provider. So this would be a long-running command that does polling to some feature flag server. So we have a feature flag provider. We tell it, get me the full configuration. Every 5 seconds, we do that in a loop. And we set the vars, that is basically the JSON that comes from the open feature flag server. That's blocking, that's long running, it runs forever. On the HTTP side, get vars, and instantly we get the current feature flag configuration for the application. Very easy implementation. So this is how you could then read from the other side. It's a huge improvement over the state of the art because there is no network involved. So no failures could happen because this layer does not exist. It's instantaneous because we are in the same memory area. So we are just copying bytes that are already local. It's very, very fast. And everything related to the process lifecycle management is already the job of FrankenPHP. So there is nothing to do on this aspect. It's just reusing the infrastructure. This is a more involving a code example that is more closer to what I think workers should look like. So here we are writing this Redis Sentinel worker. And here I'm using a full event loop and a reactive implementation. So what this means, at the beginning, I'm getting this signaling stream to know when I need to stop. Okay? And then I give this stream to my event loop. And I say to my event loop, when this stream becomes readable, code this closure, and the closure cancels the process. That's the job of the signaling stream. There is something to do to stop when it tells us to stop. So this runs on its side. Then we create a connection to the Redis Sentinel. So we get an object, and this one is a real one, AMP. It's a PHP project that re-implemented a lot of clients to use, let's say, Redis, MySQL, a lot of stuff in an async compatible way. So here we get a Sentinel object, and in AMP async, so basically we tell AMP, the event loop, do this asynchronously. We run this loop. First, we connect to the Sentinel and we ask it to bootstrap the application. Where is the current master? So we are ready to serve the application or to serve the variables. And then we subscribe. And this is a for each, but this is really an infinite stream. The for each is going to block, and every iteration is going to mean an event has been received just now from the Sentinel. So when the Redis server Sentinel sends us a message saying, hey, new master, it's here now, not here anymore, then we do an iteration, which means we call setVars, and that's doing basically nothing CPU-wise. It just do this script works and just does a setVar when there is something to do, which means usually there is nothing to do, and from time to time, there is something to do. On the HTTP side, we call getVars for every single request. And because the values don't change, this is pre, because same process. So it's extremely fast. So design principle of this, sidekicks, those are Symfony commands. I think that will make integrating stuff very easier. The application decides which sidekicks to start. There is not a list in the CADI file configuration of all the existing sidekicks. I want the PHP side to know which sidekicks it needs to start, and then that's how it works. I will come back to this later. Crash recovery, we talked about that already. There is no serialization, to transfer state between threads. We need to be careful because threads is true parallelism, and it means locks needs to, mutex at least, needs to be taken care of, stuff like that. So basically, the communication process is optimized for performance. It's also atomic. So when you do a setVars, you do it all at once. You can't have partial state. And zero overhead. I already mentioned that a few times. So there are a few more use cases, of course, like in general health service discovery. So I'm talking about Redis, but it could be about where is my MySQL, or I don't know. Health monitoring, because you could push updates there. Have a worker that monitors the health of the system and pushes the health status in a sidekick on the whiteboard, so that everybody can then read the health of the system. Very interesting stuff is going to be cache invalidation. This is a perfect process to listen to the outside world and receiving in real time cache invalidation events. This is really difficult to do in PHP today, to react to cache invalidation that comes from the outside. And with this, it's going to be super easy. The sidekick monitors the outside world, receives something that says, hey, invalidate this tag, this set of URLs, this set of objects, and then the worker does that, and HTTP is always fresh. So that's everything I talked about is PHP, not Symfony at all. And that's great, and that's really what matters to me. I want this to be kind of the new ground zero of PHP. Ground zero of PHP is PHP FPM. Everybody knows that they can build on top of PHP FPM features. I'd like to, my idea, my vision would be that everybody is now using FrankenPHP because they know that there are superpowers there to leverage and to build on. So in Symfony, I also want great integration. So this is not done yet. We are still, so everything I showed also is also just a pull request at the moment. I'm talking with the maintainers to get a consensus of what this is going to be exactly. And I still anticipate how I want this to be consumed on the Symfony side. So as you understood, I want this to be Symfony commands. And likely using an attribute, you will then be able to say, hey, this is a Symfony command, but it's also a background process for FrankenPHP. And this is how the discovery mechanism will kick in to make it work. So the experience I want is, hey, Composer require Redis fancy bundle. So I install a bundle, a plugin in the Symfony application, and just because I installed it, it's there. The sidekick is running. The integration with the services, etc., all works without doing anything. That's the perfect experience I want to optimize for. So we have a mechanism in Symfony that is called auto-configuration that would do the discovery and everything. And then there is something that is not in Symfony yet. I opened the pull request while yesterday I came by flight. I opened my laptop and I had no network. And so I had to code without an LLM. That was a bit scary, but I still can do it. And so when I arrived, I submitted this pull request to have this, to ship this attribute, auto-wire env closure. So at the moment, we have a problem in Symfony, and it's also in every PHP application. It's that when we read an environment variable, we get a string, and we inject the string in the constructor of the connection object, let's say to Redis. And then this object has this string that is not an environment variable anymore. It's a string. So how do you change the connection when the environment variable changes? You cannot. You have to stop the service and reboot and recreate the object all the time, right? So here I'm working with, and we're discussing with the community about providing a way to get a closure instead of a string. And the closure, when you call it, it returns the fresh value of the current environment variable. As you can see, I told at the beginning about variables like getVars, setVars, and here I'm already anticipating some integration and exposing those variables as pseudo environment variables to applications, because every application knows how to deal with environment variables. So if my stuff can look like an environment variable, then it's super easy to integrate, right? And that's it. You have all the pieces together. Last stuff, I want this to be able to degrade gracefully, like we do graceful degradation on the browser side. On the server side, it would mean, hey, you're using your application on FPM, not FrankenPHP. You don't have this. That's fine. We are going to do the run trips that we could save with FrankenPHP, but we are going to work still in degraded mode, doing the extra run trips because we can. So that's how this is code to write. It's not written yet, but that's the vision. And as a bonus, at least for development, also for small applications, this is the kind of configuration you could use, and you can use if you check out and compile my pull request, to have one single process that runs HTTP workers, Symfony Messenger, so job queue, plus sidekicks, all in one, just one command. Today, if you want to deploy a Symfony application, you have to deploy a message consumer, one process to monitor, HTTP, an HTTP server, an FPM server. So that's already 3 things to coordinate and to monitor, etc. So it's already complex. You don't have sidekicks. As sidekicks, as external processes, you have something that needs a bigger ops configuration. Here, we kill the ops. We just have one configuration file, a few lines there, and FrankenPHP is going to monitor everything at once. Just one thing. For development, I think it's going to be nice. What's next? That's already big. I could stop here, I think. I think if we achieve that, we already pushed the walls of the PHP room. So what's next? People want to be able to start tasks from the HTTP side, so maybe tasks. And they also want, I know I want at least, and many others, want to be able to leverage background workers from command line scripts. Like you start a command, and the command in the background manages a few threads and to offload tasks and better use the CPU, stuff like that. So the CLI part needs some patches on PHP itself. So it's blocked at the moment. I hope it's going to be merged when ready. And tasks is already something I worked on. So it's a pull request also, but first I need the previous one to be merged because this one builds on top. And task would be something that is like an API to send tasks to a background worker, get updates from the task progress meters, for example. And at some point, some coordination to say, hey, I'm done, or on one side, or on the consumer, on the caller side, say, oh, I want to cancel this task, right? So this is the kind of stuff you could do. Another stuff with the same API, just a different graph to explain the concept. You would have HTTP workers that send tasks to a task queue, and then you could have many threads that listen to the same task, kind of task, and they all manage, I don't know, image resizing or what you want. And if you have 4 workers, they could do that and use all CPUs to saturate your machine, your container. The API could be like that, like we call task send to the image resizer worker with the name of the file to resize. We get the task object. Then we call task read, and task read is the result, let's say the generated file, and then we close because it's a stream, and we're done. And on the other side, we get the same signaling string I told you about to stop, but this one, we're using it to know when to do something. So we listen to that stream, and if you see here, we say, when there's a task coming in, we receive it, we process it, and we call task update to say, I'm done, and we close the task. And that's it. That's what I want. I told you already about that. PHP FPM, today, I think it's outdated. Like, there are also features that PHP FPM, because fast CGI doesn't allow it. 103 early hints response codes, those are optimizations that browser can leverage and that are not accessible to regular PHP application that need FrankenPHP. So that's really FrankenPHP, the thing I think should replace PHP FPM. It's not that there yet in terms of numbers, but I think the code is ready for prime time. So give it a try. Just try replacing PHP FPM by FrankenPHP. And one day, when my pull request will be merged, you will get also that as a bonus. Thank you. Thank you very much.